Literature Review Presentation for Group 31, Enhanced Oil Recovery for the Hart Butte Field by Yui Tran, Dominic Mouillet, Christopher Brignac, Laxman KC.
Hart Butte Field lies within the Middle Bakken Basin. It is a low porosity, high permeability, and naturally fractured dolomitic siltstone, dolomite, and limestone. And because it is a tight oil reservoir, water flooding may not be the best option. There are many methods already being applied for this specific region, such as steam, polymers, CO2, nitrogen, and natural gas injection. For our project, we will mostly focus on the use of gas lift, ethane-based EOR, and polymer injection.
Modern gas lift unloading operations use multiple injection points, which leads to greater cost and risk of leaking. With the methods of this research, a single bottom hole valve would cut cost and reduce risk of leakage, and it would not have much impact on production activities. These methods enable a reduction of injection pressure significantly by injecting a mixture of liquid and gas, rather than gas alone. This work has already proven to be beneficial with an optimistic future, but more research must be conducted. Investigation of the effects of two-phase flow through gas lift valves needs to be investigated further. Injection during gas lift unloading is more efficient using these methods, but the life of equipment must be proven to be worth the trade. This research is relevant to my team's project in the North Dakota Hart Butte Field. The management in the future will likely consider gas lift as this reservoir depletes, and the research applying to this field will cut costs and preferably simplify gas lift processes.
In the past 20 years of U.S. oil production, CO2 has been a very popular option for EOR, especially onshore. This is mostly attributed to advanced technology, low risk, and low prices. The major problem, however, is that as CO2 EOR becomes more popular, the supply at a low cost becomes more of a concern. Current estimates are already projecting the demand to far exceed the supply of easy CO2 reserves. The obvious question then becomes, where do we turn for a viable substitute? Tests were carried out to answer this question in the 1990s by using ethane in a West Sac sample of viscous oil. The tests concluded that ethane reduced the gas solubility and viscosity of the sample better than CO2 did. Not only did the ethane prove the fluid properties of the oil, but it performed much better in tests on well equipment such as coupling, which were known to corrode from extensive CO2 usage. This was a stunning finding as it begged the question, is ethane a more effective EOR injectant than CO2? In order to answer this question, you first need to know if ethane low cost and is it readily available for use. The answer to both of these is yes. Due to increased shale production, ethane prices are at an all-time low and is now being priced as a petrochemical feedback instead of being priced as a fuel. Seeing as ethane can be produced most readily from light oil and rich gas production which exists in shale reservoirs, it is fair to assume that the availability of ethane will remain constant for the foreseeable future. Due to the fact that ethane can be used well as an effective EOR method, the availability and the low-cost nature of it, and the fact that it is most effective in low permeable shale formations, we believe it to be an effective means of EOR in our well which lies in the Bakken field.
As my teammate discussed earlier, the Bakken field is the composition of upper and bottom shale and middle dolomite. The dolomite formation is naturally oil wet. That means it prefers oil over water or gas if they are in contact together. This kind of dolomite formation characteristics affects the process of secondary or enhanced oil recovery process. The preference of dolomite to the oil reduces the oil recovery because it prefers to stick with the formation and more injected fluid such as water or gas is produced instead of oil. Fortunately, the wettability can be altered by injecting different kind of fluids that does not damage the formation and makes the oil undesirable to the formation and moves oil out of the rock. There are some research and practices to modify the interfacial properties between dolomite and oil by injecting polymer or different type of commercial surfactants, but they have not been proved to be commercially practical. And in this project, our goal is to review more research and more practices and try to find the way to alter the wettability by changing the fluid properties economically to enhance the oil recovery.